This six-story giant is not a factory. It is not a workshop either. What you are looking at is the heart of the world's largest LNG-powered container ship. An engine so huge that workers don't repair it from outside. They walk inside it. The propeller it controls is as tall as a two-story building, cutting through oceans like a knife through water. An engine this massive needs fuel on another level. Just to start, it burns nearly 100,000 liters, and its fuel tank? It can hold 20 million liters of liquefied natural gas, equal to 6 Olympic swimming pools. That alone tells you this is not an ordinary ship. It is a floating megaproject that pushed human engineering to its limits. Welcome back to Mr. No. Even in the 21st century, when planes dominate the skies, 90% of global trade still moves by sea. At any moment, tens of thousands of cargo ships are crossing the oceans, carrying everything from tiny needles to massive vehicles. The world depends on ships more than we realize, and this story is about the future of those ships. Humans have already built enormous ships. Bigger ones are technically possible. But there is a limit. Major canals like the Suez and Panama cannot handle ships beyond a certain size. That is why modern shipbuilding is no longer about size. The real competition is fuel efficiency. This is where the French shipping company CMA-CGM stepped in. Their goal was bold: build the world's largest eco-friendly container ship, powered not by dirty diesel, but by liquefied natural gas. The ship stretches 400 meters long, equal to 4 football fields in a straight line. It is 61 meters wide and taller than famous monuments. Empty, it weighs 70,000 tons, as heavy as thousands of elephants. And when fully loaded, it can carry 23,112 containers. Placed end to end, those containers would stretch 150 kilometers. But the real challenge wasn't building one ship. CMA-CGM needed 9 identical giants, and they had only 2 years. What followed was a race against time that demanded precision planning and near-perfect execution. The contract was awarded to a massive shipyard in Hong Kong, so large it operates like a city. Around 6,000 workers from across the world work there day and night, each assigned a specific role. Normally, building a ship takes around 18 months. So how do you build 9 in 2 years? The answer was modular construction. Each ship was divided into massive steel blocks. A single vessel required 12,660 steel plates, cut using lasers heated to 18,000 degrees Celsius hotter than the surface of the sun. These lasers sliced steel with extreme precision, cutting a total of 880 kilometers of metal strips. From these plates, blocks were created. Some were room-sized. Others were as tall as multi-story buildings. Each block came pre-installed with pipes, wiring, and systems. When assembled, it was like building a ship using giant Lego pieces. One section alone weighed 790 tons. Lifting it required 2 enormous cranes. Even a 1-millimeter mistake could destroy months of work. There was no room for error. Once the blocks were positioned, the real test began: welding. Over 1,250 kilometers of welds were laid down on a single ship. That's like welding the distance between major cities. The ocean shows no mercy. Every weld had to be perfect. Inspectors checked each joint carefully, because one weak point at sea could mean disaster. But steel alone was not enough. This ship was designed to run on LNG, a fuel that produces 99% less sulfur, 91% less air pollution, and 20% less carbon dioxide compared to traditional fuels. The biggest challenge was storage. LNG must be kept at -161 degrees Celsius to stay liquid. If it warms up, it expands rapidly and becomes dangerous. To solve this, engineers built the largest LNG tank ever installed on a ship, 18,600 cubic meters, holding 20 million liters. But a tank alone was useless without protection. Engineers essentially had to build a giant thermos flask inside the ship. The LNG tank required extreme insulation. Multiple layers were installed to prevent heat from entering. Every joint was tested using soap water and vacuum pressure. Any tiny leak was repaired immediately. Finally, a 1.2 millimeter steel membrane was installed. This membrane expands and contracts with temperature changes, a technology also used in space stations. After 8 months, the world's largest thermos was complete. Then came the engine. This was not just big, it was historic. The world's largest LNG-powered marine engine stands 20 meters tall, weighs over 2,000 tons, and produces 85,000 horsepower. It is so large that technicians walk inside it for maintenance. Transporting it required 6 separate shipments. Its most critical part, the 220-ton crankshaft, was delivered on a remote-controlled platform with 140 wheels. The engine uses 12 pistons, each 1 meter wide. These pistons drive a 92-ton propeller, cast in a single piece and standing 10 meters tall. Absolute precision was required. Any bend could cause violent vibrations. Once the structure and engine were complete, the ship needed protection. Oceans are brutal environments. Salt water corrodes metal, waves punish weak surfaces, and marine organisms slow ships down. To protect it, engineers used nearly 1 million liters of special paint, covering 9,500 square meters, an area twice the size of Vatican City. This coating reduces drag, improves efficiency, and protects the hull for years. Then came the final piece, the command bridge, the brain of the ship. Advanced systems were installed, including smart eyes, giving the captain a full 360-degree view of the surroundings. Every system was tested: navigation, emergency braking, leak detection, anchor deployment. One link of the anchor chain alone weighs 300 kilograms, and the entire chain equals the weight of 60 elephants. After 18 months of non-stop work, the first ship, Jacques Sada, was ready for sea trials. For 15 days, it was pushed to its limits. During sea trials, nothing was left to chance. Speed tests were conducted. Emergency systems were triggered. Structural integrity was checked under real ocean conditions. The ship passed every test. With that success, the rest followed. One by one, 9 megaships were completed in record time. CMACGM achieved something no one thought possible: massive ships that were not only powerful, but cleaner and more efficient. These ships are not just machines. They represent thousands of skilled workers, engineers, and technicians who worked with extreme precision under tight deadlines. They prove that progress is not only about building bigger, but building smarter. This is not just the story of steel and engines. It is the story of human ambition, discipline, and teamwork. A reminder that when knowledge and effort come together, limits disappear. These megaships now sail across the oceans, carrying the world's trade, using cleaner fuel, and setting a new standard for the future. If you enjoy real engineering facts and unbelievable human achievements, make sure to like this video, subscribe to Mr. No, and turn on notifications.